Hey grade 10s. Okay, so as you can see here, we have multiplying and dividing rational expressions all in one lesson, but I'm actually going to break this up into two shorter videos, okay? So I'm going to spend this first video doing all of the multiplying questions, and then I'm going to stop the video, and then I'm going to start again, and I'm going to come do all the dividing questions out of the lesson, so there might be a little bit more scrolling in this video, I guess, than I usually have, but that's just because I want to break it up into two skills in case you want to kind of attack them separately, and I'll also be putting up some additional worksheets that are separate from each other, like one multiplying worksheet and one dividing worksheet. So yeah, okay, well, let's get started. So we're going to start here with multiplying and dividing rational numbers, and so like I'm saying in this video, it'll only be multiplying, okay? So I want to remind you that when we multiply rational numbers, that's like multiplying fractions, okay? All we do is we multiply the numerators, and then we multiply the denominators, okay? So 2 times 5 is 10, and 3 times 7 is 21. And if there was something to simplify, we would always do that. We always want our answer in lowest terms. In this case, there's nothing. The answer is there. We can put a box around it. Okay, I'm going to go across here to 8 over 5 times 10 over 9. Now, two ways to do this, okay? So you can either do what we just did, okay? So you're going to get 80 over 45, and then you can reduce, okay? That's totally fine. Absolutely, you can do that. You can see those are both divisible by 5. Go for it. However, I would recommend that we're going to level up a little bit here in our math skills, and we're going to do some cross-canceling, okay? In fact, I'm always going to recommend that we cross-cancel where we can. We can see that 10 and 5 both have a common factor of 5. Okay, I can't write apparently, you guys. Wow. 2 and 1. That's what that reduces to. If I was writing this on the board, it would look a little bit better, but you get the idea. And then I'm going to multiply across, okay? So then I'm going to do 8 times 2, which is equal to 16. And I'm going to do 1 times 9, which is just 9. And again, if there were any common factors, we were going to reduce, but there are not. So there we go. That's an answer. Okay, moving back across the page here. I'm going to do this next one. I'm going to recommend again that you guys cross-cancel, okay? So you can see that 4 and 8 both share a common factor of 4. So that actually does also reduce to 2 and 1. But 9 and 12 also share a common factor, okay? So that is going to give me 3 over 4 when I divide both by 3, okay? And I'm going to multiply now. 3 times 1 is equal to 3, and 2 times 4 is equal to 8. And that, again, has nothing left to reduce, which is great. Now, a good sign that you've done good cross-canceling is that there's no reduction left to do at the end. But, of course, if you only cross-canceled one of those things that I did before, and then you had to reduce after you did the multiplication, that's totally fine, okay? Another quick note that I'm going to get, I know I would have gotten in class for this question, is, well, but Mrs. Friesen, you could reduce 4 over 12. Okay, that's a fact. You're not wrong, okay? I could have cross-canceled differently in this case, okay? I could have just reduced 4 over 12 to 1 over 3, like right away. And then I would have reduced this 3 and 9 separately afterwards and then multiplied. That is fine, okay? You absolutely could do that. However, this is just the thing that like kind of jumped out to me first, so I did it first, but there's nothing wrong with either of those methods, okay? So here we go, 20 over 7 times 21 over 12. Here's a great example of why we cross-cancel, okay? There is in no universe that I want to multiply 20 by 21 and then multiply 7 by 12 and then reduce that. That sounds crazy. We have a number in the 400s divided by 84. Like, that sounds terrible. So I'm going to cross-cancel. Okay, so the first one that jumps out to me here is that 21 and 12 both share 3. Okay, so that's going to give me 7, sorry, just like lost my train of thought for a second. 7, when we divide by 12 by 3 gives me 4. Okay, so I just divided both of them by 3. And then I'm also seeing, again, I'm going to change pen colors so you can see that I'm doing this kind of in 2 steps. I'm also seeing a 7 on the top and a 7 on the bottom, so I'm going to reduce those as well, 1 and 1. And this is getting a little bit crazy, so I'm going to just multiply across now. So I have 20 times 1, which gives me 20, and I have 1 times 4 in the denominator, which gives me 4, and I can see that I can reduce that even further. Let me write this a little bit neater. Hold on one second. 20 over 4 there. That's much better. Okay, so I can see that 20 over 4 is a number that I can divide, right? We know what 20 divided by 4 is. It's 5. So there we go. That would be our answer. I guess I should put a box to stay consistent. Okay, so why am I talking about all this stuff? Cross-canceling and blah, blah, blah. That's because when I multiply and divide rational expressions, it's very similar to multiplying just rational numbers or fractions. So the only major difference is that we just need to keep in mind that there are NPVs, okay, non-permissible values for rational expressions. So when we multiply, we're going to just, again, look at what are the denominators, okay, that are in both of the fractions, and then what are the values that would make the denominator 0. So same as when we did the simplifying lesson last video. Okay, so in this question, it's just asking us to multiply and simplify, stating all NPVs, and you may leave your answers in factored form. This is very important, okay? This is going to be true for all the work that we do. You can always leave your answers in factored form. I think in the answer key of a couple worksheets, I may not have. I think I did. But if I didn't, just let me know. I can correct that, okay? But you can always leave your answers in factored form when we're doing this mini unit, okay? Because like just multiplying it back out afterwards is kind of dumb. I'll show you what I mean when we get there. Okay, so we are going to start with NPVs, okay? So just gonna make like a little note over here. We can see that x minus 3 can't be 0. Oh boy, that's getting really messy. Can't be 0, but because this is a skill we've already practiced, I'm actually just gonna start by writing these out like this, because we can see that x minus 3 can't be 0, so that gives us this. And then x minus 1 can't be 0, so that gives us this. If you need to still write it out the way I was writing it out in the first lesson, that's fine. But most of you, I think, by now will be able to kind of just like see it a little bit better. Except for the factoring ones, if that you need to write that out more, of course, that makes sense. But if you don't want to write out the whole step situation for finding the NPVs, that's fine. Okay. Okay, so now multiplying works exactly the same way as it would work if we were talking about a regular fraction. I'm just going to multiply the tops and then the bottoms. If I was being more mathematically precise, I would say the numerators and then the denominators. So we're going to get x minus 2, x plus 1, and then I'm going to have x minus 3, x minus 1. Now, we are going to see if we can reduce. And what we're looking for, again, is identical sets of brackets, okay? So I'm not going to cancel any of these x's because they are connected by addition or subtraction to the other terms in the brackets, okay? So if I can't cancel the entire factor, I can't cancel any of it, okay? And so because you can see that these are all different, even though the x's are the same, like the whole factor is not identical, then we can't cancel anything. That's fine. That just gives us our final answer. So we have this as our final expression, okay? That's the final thing. And then we are just going to add our NPVs into our final answer. Whoops. There we go. There. Okay. Voila. All right. So next example. Sorry about the weird noise. Just had to move my iPad. We are going to do the same thing. Okay, so we have some NPVs going on. And we can see that x cannot equal negative 7. And that x cannot equal positive 1. Okay, now when I do this multiplication, we're going to just multiply across. Okay, so you're going to see that I'm not doing any sort of FOIL or distribution in these questions. And that is because, remember what I said at the top, we do not have to do that because we can leave our answers in factored form. Okay, and so there's no point in taking it out of factored form just to put it back into factored form. That seems crazy. Okay, now we're looking for identical brackets. Okay, so I can see that we have a winner here. We have x plus 7, x plus 7. They are identical, and so because of that, we can cancel them out. Okay, so then that leaves me with a simplified x plus 2 over x minus 1. That looks like a plus. Let me try that again. There we go. Where x cannot equal negative 7 or 1, and that's a final answer. Okay. Let's move down the page here. I'm going to change colors and zoom in a little bit, just so we all have lots of space to see what I'm writing. Okay, so we're seeing that Mrs. Reason made a typo. Are you surprised? You should not be. This is supposed to be an R, and so is that. Okay. Once I've rectified that situation, we can see another problem, which is that we have some unfactored situations here, right? We have some expressions that are not factored. So we're going to have to keep that in mind when we do the simplification here. But as always, I would like us to start with finding our NPVs. Okay, so first one is r squared minus 9 cannot equal 0. And this one we do have to factor, right? So in this case, I can understand when we need to write out the whole thing a little bit more often. That's totally fine, okay? So we're going to get from there that r can't be 3 and that r can't be negative 3, okay? And then from here, r plus 2 can't be 0. So then, wow, that looks like a 6. There we go. So then r can't be negative 2. Okay, so those are our NPVs. Now, let's do some simplification. First thing I'm going to do to simplify, I'm going to factor. Okay, so I can see that this numerator here, r squared plus 3r plus 2, is going to become r plus 2, r plus 1. And our denominator, we already factored it very conveniently. And we're still multiplying by what was there before. And remember that any numerator or denominator that does not have a bracket around it already, you can just add them in. It means the same thing. Okay, and then from there, we can either cross-cancel if you see the opportunity, and if you don't, that's okay. And then we'll cancel afterwards if you didn't see the opportunity. Okay, so I'm going to do some cross-canceling here. I can see that there's r plus 3 on the numerator and r plus 3 in the denominator. They are identical. Okay, and then let's just say that's all I saw. So for those of you who have seen what is remaining, that's fine. I'm going to get to it, don't worry. I'm going to multiply across. Okay, so I've multiplied the brackets that remain in this expression, and then I'm going to see if I can reduce, again, by looking for identical brackets. The whole thing needs to be the same. So we have r plus 2 here, and we have r plus 2 here, so that's a winner. So we're going to cross those out as well. I'm going to get left with r plus 1 over r minus 3. And as we can see, that is that's it. There's nothing left to simplify, right? This is connected by addition and this by subtraction, so we cannot cancel just a piece of it. And then we're going to state our non-permissible values. In this case, r cannot be equal to negative 3, negative 2, or positive 3. Voila. Okay, last example. Just going to move over here and zoom in again. All right, let's choose a new color. I love this one. Okay, so same thing here. We have a few things going on, and I'm going to need to state my NPVs for these before I move on. So let's just do that right away so don't forget. So when I factor this, I'm going to get a minus 1, a minus 1. Now this is a new situation for us. Okay, I want to point out that because both brackets are identical, what I would be doing is I'll be saying a minus 1 can't be 0 or a minus 1 can't be 0. And so because of that, we would get the same answer both times, so you only have to write it once. Okay, so you just need to do that. And then for the other denominator, a plus 1 can't be 0, we're going to get a can't be negative 1. Wow, guys, my writing today is just terrible. I'm so sorry. Okay, there we go. So let's do some factoring. Okay, so as you can probably tell, factoring is really important in this unit. So if you need some refreshers on factoring, let me know. I can send you lots of materials. I have so many of them. Okay, yeah, whatever. I don't have actually more to say about that. Just make sure you know how to factor, and then this will become pretty straightforward for you. Okay, so again, here it is. Now I'm going to do this one by multiplying everything across right away. That's because I think a lot of people prefer to see everything all on like one big fraction instead of two fractions, and that is fine. Okay, if you want to cross cancel first, you can. If you want to multiply everything first, you can. I don't care at all. They're both great. Okay, so now I've multiplied across. We have one large fraction, right? I multiplied all those numerators together, and then I made this big numerator. And I multiplied all the denominators together to make this big denominator. And once I do that, let's see what we can cross cancel here, or just cancel actually in this case. Okay, so I can see that I have a plus 1 and I have a plus 1. Okay, and then I also have a minus 1 and a minus 1. So I can cancel those sets of brackets because they have identical counterparts in the opposite spot, either numerator or denominator. And then I'm getting left with a plus 1 and a plus 6 in the numerator and a minus 1 in the denominator. Now, you can, again, leave this in factored form, okay? In fact, I would prefer it. It is easiest. And this is accepted as a simplest form, okay? It's not like there's extra work left to be done in this case. We wouldn't count it that way. because I gave you that direction that you may leave your answer in factored form, okay? And we also need to include our NPVs. Don't forget about those, that a cannot equal -1 or 1. Okay, that's it for this. The next page is all dividing, okay? So I'll do that in the next video. But I did just want to make like one quick note that if you get any of these original questions like these here, and then you factor them, and then you get a bracket that doesn't have an a value of 1, what do I mean by that? I'll show you. Just hold on. Just pretend this is like a thought bubble. Okay. Oh, interesting. That's not what I wanted. There we go. Okay, so if I had a bracket, let's say that I had 2x minus 3 times x plus 1 cannot equal 0, let's say this was a denominator, then you would still, again, just set both brackets not equal to 0. And as you can see, this second bracket is just normal, but this sometimes throws people off, so I just want to make a quick note because I know it does show up in the homework somewhere. I can't remember if it's in the booklet or in the additional homework, but it does show up, so just hear me out on this. You start the same way. You're going to move that 3 over to the other side, okay? And then once you do that, you're going to just divide both sides by 2, because remember, we're always looking for what x cannot equal, not what 2x cannot equal, okay? So then this and this would be your set of NPVs. It's fine that there's an NPV that's a fraction, okay? So that's really important. Okay. There we go. That's multiplying. Okay, if you have any questions, message me, of course, and we will do these dividing examples and then the next page in the next video. Okay, talk to you soon.